Alright. On the screen, please, on the screen. You guys are saying, asking me what grade it is. It's on the screen. Yo, it's on the screen, guys. It's on the screen. Right. Revolutionary greetings to everyone. Yeah, we are doing this grade 11. We know that the night slot is for the grade 11s and the grade 12. So we're doing grade 11 now. And I just want a verification first and foremost in the comment section. How is the network? Is it networking or is it unnetworking? Is the network okay? Or is the network off? If it's off, let me know, man. Yeah, let me know, please, in the comment section. Really appreciate that. You shouldn't be able to see yet. There's people who want to see all the time. You guys are talking about bad, you can't see. I'm not talking about bad about that. I'm talking about bad. I want you guys to let me know as far as can you hear me? Am I audible? Not you can see. I have not shown anything yet. It should be a white screen in front of you, a bit blurry. That's how it should be. What I'm wanting to check is fluency in communication, and can you hear me? Am I audible? There's no lagging. Tlotleho is saying, okay, you can hear me, but my question is, are we kicking? Do you guys sense a lag? Okay. Okay, I can hear you. So it seems like certain individuals can hear me. Seems like certain individuals can't. Okay. This is me hoping that things will be better. Hopefully they will be. And Boitumelo is also saying network. Network's not good. Not great. What is the lag? What is it, guys? Just tell me in the comment section. Am I audible? Am I kicking? What's happening? Now is the time to answer in the comment section. Network good, network bad, network okay, network nonsense. What is it? You're audible but not visible. I'm not supposed to be visible. I am not supposed to be the one that's visible. Can you see this word here? This one. If you can see this word that I have here, this one that the pen is pointing to, can you see it? That's what should be visible. Boitumelo, you can confirm for me. You can confirm for me if you can see this word. So Tapelo, this is grade 11, and then we're doing grade 12 at 10:30 as agreed. Alright. What's happening now? Siyabonga Matabele, as I said, grade 10 will be tomorrow, 8 a.m. Grade 10 tomorrow, 8 a.m. Grade 9 is going to be at 7 a.m. Grade 12 is tonight at 10:30. We are currently busy now with grade 11, or we're about to start with grade 11. But I just want to confirm that my network is fine so that I can continue and proceed. I just need the people that are here to confirm for me that network is fine, lagging has ceased, or lagging is still happening. Blade Boy is saying proceeds, meaning the lagging is not there. Network is fine now. Okay, Elihle, if you have confirmed, Elihle is my person that is basically confirming everything. Alright, guys, today we are starting this new section of work called your network is still bad. Unfortunately, Tipo, I think if the network is still bad with you, then it must be the network with you. I'm very sorry about that. So we are going to start quadratic equations and quadratic inequalities, right? Quadratic equations and quadratic inequalities. But before we go into the actual equations and inequalities, we're going to look at a section that comes before we jump into equations. All right. Now, when you were in grade 8 and 9 and going up to grade 10, you should have made a clear distinction between two things: what an equation is and what an expression is. All right. The difference between an equation and a expression. I'm hoping that everyone who is on this call knows the difference between what an equation is and what an expression is. All right. It's very important to know that difference. What an equation is and what an expression is. Mathematically speaking, in algebra, what those two are and their difference. So we are going to look at specifically now under quadratic expression. We are going to look at how to find the minimum or the maximum value of and this is the wording, of a what? Of a quadratic expression. Okay. Now, quadratic seems to infer that you have an x squared term followed by an x term followed by a constant term. This here is a trinomial, meaning it has three terms, but we call it a quadratic expression because its variable x, which is dominant, the variable x, which is dominant, has a highest degree, which is 2. X squared. So that's why we refer to this as a quadratic expression. Okay. So once again, to those who are coming in grade 11, we are busy with grade 11 here. Okay. And we are looking at how to find the minimum or the maximum value of a quadratic expression. All right. So let's start. Now it's very easy to what? To determine the maximum or the minimum if our quadratic expression is in the form, and this is very important, which form? If the quadratic expression is in the form a brackets, which means into x plus p close brackets, the whole thing squared plus q. So if we have our quadratic expression in this form, it is so easy to do what? To determine the maximum or the minimum. Okay, if our quadratic expression is in this form. Okay, so this is very important. All right, that in order to determine the minimum or the maximum value of a quadratic expression, we need to have our quadratic expression in the form a into x plus p, the whole thing squared, plus q. Remember, the a and the p and the q simply represent variables which are standing in the place. All right, we can replace real numbers in the place of those variables a, p, and q. Right, let's go further. So if we look at this example 1, if we look at the quadratic expression x squared, just x squared alone, x squared has a what? A minimum value of what? Of 0. Now, you're going to sit here and be like asking yourself, what do you mean it has a minimum value of 0? Okay. Now, Boy Tumelo is saying you are jamming up, sir. So I need to just get a whole class understanding. Okay. So Boitumelo is saying I'm jamming up. What about everybody else? What is your experience? Are you guys also experiencing jamming up, or what do you call lacking? I think that's the term there. So Boitumelo, there must be a there must be a challenge with your network. Okay, because the other Boitumelo 16 says that it's fine. Okay, so Boitumelo, it might be your network, and sometimes what usually helps with that is if you kind of log out of TikTok and then you kind of switch off your phone, you switch it back on, and then you come back, you try and come back, you see. Okay, so back here, x squared, this is a quadratic expression, all right? It has a minimum value of 0. Okay, now, the question you may be asking yourself is, why in the world would we say x squared has a minimum? Why aren't we saying x squared has a maximum? Why are we saying it has a minimum? And how do we know that it is 0? So let's look at this. If we take x squared and we write it in this form, a into x plus p, the whole thing squared plus q, this is the form that we have. First and foremost, the a is 1. Inside the bracket, we have x minus 0. And then we close the bracket, the whole thing squared, plus 0. Look at the 1. The 1 is standing in the place of a. Inside the bracket, we have x, where we had x there, minus. Now, whether it's minus or plus, it makes no difference. In this case, because it's 0, whether it's minus or plus, it makes no difference because 0 as a number is a neutral number, okay? It's neither positive or negative. So p here is 0. Then we have the squared, the square, plus q. In the place of q, we have 0. I'm sure if you guys know your expansion very well, you know very well that if you were to take this and actually multiply it out, x minus 0 gives you x inside the brackets, the whole thing squared with the 1 on the outside plus 0. In actual fact, this is the expression x squared. But what have they done to this x squared? They've written it in this form, a into x plus p, the whole thing squared, plus q, all right? And therefore, what do we conclude when we have this form, this particular form? We can therefore say that 1, x squared has a minimum value of what? Of 0. Where did we get the minimum value that is 0? The minimum value that is 0 is simply the value that is standing in the place of q. That is the minimum value. But how do we know it is the minimum? We know it is the minimum because a, meaning this value here, when this value of a is positive, all right? You'll remember last year when you did functions, you know, when a was positive, you spoke about smiley face, like a function that has a smiley face, and smiley face, it means it has, you know, this turning point here, and this is basically what we call the lowest point of the function, which we refer to as the minimum. Are you with me? So when a is greater than 0, it means we have a minimum value. We don't have a maximum, we have a minimum because a is greater than 0. Then how do we know what the value of the minimum is? We look at the q value. The q value gives us the value. Okay. So a tells us, are we minimum or maximum? Then q tells us the actual value of the minimum or maximum. We said that when a is positive, then it means that we have a minimum. That is why they are saying x squared has a minimum value. Why? Because the coefficient of the bracket is positive 1, which means a is positive. Then how do we know the actual value of the minimum value? It is 0 because q, when our quadratic expression is in this form, the value of q tells us the value, okay, that basically we are saying the minimum or the maximum is. So that's why they are confident in saying x squared has a minimum value of 0. Okay, when we know that when x is equal to 0, in other words, when you take this expression inside the bracket, you take it, you equate it to 0, you solve for x, you get x is equal to 0. All right, so there's a couple of things here. We know that x squared has a minimum. Why do we know it has a minimum? It's because the coefficient of x squared is a positive value, which means there's a minimum. Step number 1. 2, the value of the minimum is 0. How do we know that? It's because the q value will give us the actual value of the minimum or maximum, depending on a. Then lastly, what is the value of x that gives us this minimum that is 0? We take the expression inside the bracket, we equate it to 0, then we solve for x. X is equal to 0. So we know that x squared has a minimum value of 0 when x is equal to 0. Okay, so that's the first example. Let's look at another example, guys. Look at another example. Example 2. What are they saying here? They are saying minus x squared. Now look at this. Minus x squared has a what? A maximum. Habe. Negative x squared has a maximum. Oh, so negative x squared has a maximum value, but x squared had a minimum value. Okay, so what informs this thing of them saying negative x squared has a maximum value? It has a maximum value of 0. Now, what informs them saying we have a maximum value of 0? Remember here, the coefficient of x squared is negative. If we look at this negative x squared written in the form of a into x plus p, the whole thing squared plus q, this is the form that we get. Negative 1, in brackets, x minus 0. The whole thing what? Squared, plus 1, plus 0. So, a, what do we know about the a value? The a value in this case is less than 0. Remember when we did functions in grade 10, what did we say about a function when the coefficient of the x squared term is negative? We said that the function is, since the coefficient is negative, it has a set phase. Set phase would suggest that this function has a maximum because there's a top value, all right, in this case. This is informed by what? By a. When a is less than 0, we have a what? A maximum, all right? Oh, so when a is less than 0, meaning we have a maximum? Yes, indeed. Oh, and then for the previous one, when a is greater than 0, we have a minimum. Yes, that is very true, my child. Hey, you are getting it, my child. I'm very proud of you. All right, moving right on. So negative x squared has a what? Has a maximum value. Now, what is that maximum value? It has a maximum value of what? Of 0. Why are we so sure that it's the maximum value of 0? Once again, what did I say informs us of the value of the maximum? We look at the q, okay? So the q here is 0, right? Which is very important. So negative x squared has a maximum value of 0 when x is equal to 0. How do we know it's when x is equal to 0? We take the expression inside the bracket, which in this case is x minus 0. We equate it to what? To 0. Then we solve for x. X is equal to 0. So the maximum value is 0 when x is equal to 0. All right. I think it's coming, this thing, it's coming. It's coming. All right, let's look at the next example. Example 3. X minus 1, the whole thing squared. Hold on a minute here. X minus 1, the whole thing squared. So we are moving now. It seems like our square term, all right, or our square expression is a binomial, whereas in the initial problem, it seems like we had a monomial. All right, so here, x minus 1, the whole thing squared. What are we learning now? If we look at this, this seems to already speak of this form, or it's already in this form. All right, it's just that the p-value is not 0, but it is actually negative 1. Okay. So, x minus 1, the whole thing squared, we are told has a what? A minimum. Are they justifying it in saying it has a minimum? Yes, it's because the coefficient of the bracket is 1 and it is positive. Okay, then so 1 into x minus 1, the whole thing, has a minimum value. What is the minimum value? The minimum value is what? Is 0. Why are we saying it's 0? Remember, guys, that if we were to write this thing in its full form, 1 brackets x minus 1, the whole thing squared, what would be the constant term? It would be still 0. Remember, in this form, a tells us of the, is it maximum or minimum? When a is 1, when a is positive, we know when it's positive, smiley face, minimum. All right? 2, what is the actual minimum value? The q value, which is in this case is 0, gives us the minimum value. Then when is this expression having a minimum? What should the x value be in order for us to have this minimum value of 0? Then in order to find that out, we take the expression x minus 1, we equate it to 0, then we solve the equation. In other words, the additive inverse of negative 1 will give us the value of the x value, which gives us the minimum. So when x is equal to 1, the minimum value of this expression is 0. Okay, very key, this thing. Very, very key. Okay, let's move on. Next, example 4. It seems like this thing is coming. Minus into brackets x minus 1, the whole thing squared. All right, hold it. Is this already in this particular form that we need in order to be able to determine if this is a minimum or maximum? It seems like it is. Negative x into x minus 1, the whole thing squared. Just that the q value, we are missing that. So if we were to write it out and write the q value out as well, we know that there's a what here? There's a 0. So minimum or maximum? That's the first question. This negative, does it tell us we have a minimum or a maximum? Which one do we have, guys? Is it a minimum or a maximum? Based on the value of a. The value of a is negative. So are we talking about maximum or minimum here? Okay, Oradile says maximum. Getzo as well. Junior as well. And blade. Blade has a blade that cuts through everything, and so we can definitely agree and say it's definitely here a maximum, right? Remember that negative, the a when it is negative suggests that our expression, which can also be indicated as a function, is concave up, concave down, which means it's a sad face, and therefore at the top we have what we refer to as the maximum. Why? Because a is less than 0. 2, what is the value of the maximum? Where do we look at when we are looking for the value of the maximum? The actual value of this maximum. So we know we're looking for the maximum, but what is the maximum value? What is the maximum value? Okay, so it says 0. I'll only close the answers when Blade answers, and then he will cut the thing and we can continue. Totlego says 0 as well. Okay, so the max value, it seems we are agreeing to some degree that it's 0. Totlego says 0. Precious says it's the maximum. Definitely it was the maximum that we agreed on, but what is the actual maximum value? Yeah, it went off because I'm quiet. I'm still listening for people to answer. Okay. So the maximum value is 0, right? Very true. And then when is the maximum value 0? When x is actually equal to what? When x is equal to what is the maximum value 0? When x is equal to what? Where do we look in order to get an understanding of the value of x, which gives us the minimum? When x is equal to what exactly is the maximum equal to 0? Okay, Dotlejo answer. Dotlejo is on the money there. When x is equal to 1. Remember, what do we do there? We go and take the expression inside the bracket, x minus 1. We equate it to 0. Then we solve it. So x minus 1 is equal to 0. We transpose the negative 1. We get x is equal to positive 1. Okay. Guys, just from the expression itself, we are able to, from the a value, determine whether it's a maximum or minimum. Remember, when a is negative, then we know that our function, if we were sketching a function, would be a concave down function, meaning it would be a sad face. Sad face means at the top we have a maximum. So here, whenever the a value is negative, we are talking about having a maximum value. 2, what is the value? What is the maximum value? In order to get that, we look at the constant term, the value of 2. So the max value, if we were to write down what is the max value, we'd say the max value is equal to 0. When is the max value equal to 0? In order to get that, when is the max value equal to 0? When x is equal to what? So to determine that, we take the expression inside the bracket and we do what? We equate that to 0 and then we solve for x. X is equal to 1. Okay, so therefore, these are 3 fundamental important things that you are getting from what? You are getting 3 fundamental things from A. 1, whether it's maximum or minimum. A will tell you that. The inverse value of P, in other words, the opposite value of P, will give us what is the x value that gives us a minimum or maximum. Then Q as it is gives us the value of the maximum or minimum. Okay, so that is why this form is so important. A quadratic expression must always be converted from, if it's in this form, guys, we need to somehow convert this quadratic expression to this form so that we can be able to identify. We can firstly point out, is it a maximum or a minimum based on A? What is the x value that gives us the maximum or the minimum based on the inverse of positive P? And then what is the actual value of the maximum or the minimum based on the value of 2 as it is? Right? 3 fundamental important things. Okay, I don't know if you guys are so sick and tired of the examples. Okay, these are given examples and I'm just going through them so that we can grasp the concept. Example 5. Okay, example 5. My good friends in the comment section will help you out. I also post these live lessons, guys. After I'm done, I post them onto the YouTube channel. YouTube channel, you can find it on my bio. It's called Maths is a Game. It's the same name. All right, so I'll post this one as the grade 11 video after I'm done. Okay, which will be later on in the evening. You know, after I'm done with the grade 12 lesson. So you'll just have to be patient. If you are just joined in, yeah, so you'll find it there. Example 5. Let's look at this one. X squared plus 9. Okay, so this quadratic expression has, as they say, my question that I can ask you, x squared plus 9, maximum or minimum? If we look at this form, maximum or minimum, the coefficient of x squared, positive or negative, therefore maximum or minimum depending on the coefficient of x squared. So the coefficient of x squared is 1, so this would suggest that we have a happy smiley face, which therefore means that we have a minimum, definitely. 2, what is this form an appropriate form? Okay, x squared plus 9. So x squared plus 9 can be written as 1 into x minus 0, the whole thing squared plus 9. I'm sure you guys can see that, guys. This 9 is a constant. This is x minus 0, the whole thing squared plus 9. Okay, if you guys are wondering, how did you do this, sir? Don't worry, we are going to go into that, like the actual method of converting a quadratic expression into this nice form. Okay, so a is positive, which means we have a minimum. What is the value of x that gives us the minimum value? What is the value of x? Before we actually tell what the minimum actually is, what is the value of x that gives us this minimum? Okay, Totlejo is always on the money. Like you can see, he's like sitting there waiting to type. Piniti. Yeah, Piniti, you are pinitering here. Eh? So when x is equal to 0, And what is the actual minimum value, guys? What is the actual minimum value? The minimum value is equal to, don't say it all together, don't type it all together, guys. The minimum value is, there we go. You see, Beniti is just, Beniti, I'm telling you, man, the typist for days. Yes, it's 9, guys, it's 9. Okay, it is definitely 9, right? So here, we know a is equal to 1. That suggests that we have a, if you were to actually spell it out, that means minimum, all right? You know what I mean? A is positive, so a happy face, but it means we have a minimum. What is the x value that gives us the minimum? We look at the inverse, so x is when x is equal to 0. And then last but not least, what is the actual minimum value? The actual minimum value, mean value, is equal to 9. That's it, guys. I mean, how simple, how straightforward, how cool, how cute. Guys, this is cute, man. Example 6. This is the cutest thing that you guys have ever seen. If you are a grade 11 learner and you're looking at this and you're like, okay, now it's making sense. I looked at mine actually in the textbook. I tried to follow, but I couldn't really follow it. But you can see it now because that is basically our guide. This is exactly what I'm using right now. I'm using the notes from that so that you guys can actually go back. Please use that resource. The New Mind Action Series textbook is a beautiful textbook, guys. I'm promoting it. Jack Basson, wherever he is, the author, he must know that I'm promoting his textbook in these TikTok sessions because it's a brilliant textbook, right? It's a brilliant textbook. Example 6, let's look at this one. Minus into x plus 3, the whole thing squared minus 2. If you look at this, this is already in that form that we want. It's already given to us in that form, guys. Look at that. A, negative 1. I'm sure you guys can see the shape already. Negative, sad face, maximum. Do you see what I mean? Sad face also means we have a maximum, right? What is the value, the maximum value? Oh, there it is, the Q value as it is. So our maximum is negative 2. Okay. I think 9 should be the minimum since we have a positive gradient. Precious, what are you talking about? The previous example, x squared plus 9, has a minimum value. I think we spoke about that. That was the previous example. Now currently we have a negative coefficient. Remember, when we're talking about a parabola function, its gradient changes, right? Remember that if we're talking about sad face, okay, and please people, gradient is change of x over change of y. So basically we're talking about the slope. On this side the gradient is positive, but on this side the gradient is negative. So for a parabola, the gradient changes, right? The a value here is not talking about gradient. The a value is simply helping us to understand whether we have a maximum or a minimum. This is where parabola is concerned. So don't mix the two functions together, right? Let's simply stick to this concept that we are trying to explain so well from this turning point form. So this, like I said, this a value, which is negative, tells us that we have a maximum, like I said. So this is maximum, right? Because, yeah. Then 2, what is the value of x that gives us that maximum? So we take our expression, we know the inverse of plus 3 is actually equal to negative 3. So it's when x is equal to what? To negative 3. All right. And last but not least, what is the value of this maximum? So the maximum value is equal to negative 2. So I hope you guys can see that, right? Because this one, it's already in our form that we want so that we can be able to point out all these important aspects, right? So guys, in conclusion, I'm sure from this entire exercise that we've done, here is a conclusion we can make, which is general. So in general, here's the thing. If a is greater than 0, which we've seen from the examples above, if a is greater than 0, then this quadratic expression form has a what if a is greater than 0? It has a minimum value. We saw that, right? Look, a greater than 0 means positive. Positive means happy. Happy means obviously concave up. So therefore it means we have a minimum indeed, right? So you can always confirm this thing by drawing that graph of yours. Then it has a minimum value of what? Of q. When x is equal to, remember, when x is equal to the inverse of the p-value, which would be negative p. Are we together? All right. So please, people, this is a general note that we can make. If a is greater than 0, then a into x plus p the whole thing squared plus q, which is that form that we want, has a minimum value of q, okay, meaning the value of q as it is, when x is equal to the inverse of the p-value. X is equal to negative p. This is just a general statement that we can make. I'm sure then the same would be true if a, let's change the greater than to less than. If a is less than 0, then what? Then a into x plus p the whole thing squared plus q has a, we would say, a maximum value of q when x is equal to negative p. That's how the statement would change if we said if a is less than 0. If we change the statement and said if a is less than 0, then we don't no longer have a minimum, but we have a max value, and it still is of q when x is equal to negative p. So this is generally speaking. Okay, guys, I hope that we all have an understanding of the effect of a, of p, and of q, and how it helps us to be able to do what? To identify whether an expression that is quadratic has a maximum or minimum, whether what is the value of the maximum or minimum, and then lastly, what is the value of x that gives us that maximum or minimum. I hope that's clear, guys. So these two statements, they are very important. Okay, now let us proceed so that we can get to the part where we can actually do something that is mathematically inclined as far as calculations are concerned and methods of mathematics are concerned. So here's something to note. When a quadratic, and this quad just means quadratic, guys, I just wrote it in short. So when a quadratic expression is written in the form ax² plus bx plus c, we refer to this as the standard quadratic form, by the way. Thank you, Luan. We refer to this as the standard quadratic form, ax² plus bx plus c. Okay, this is the standard quadratic form. We call it that. So when a quadratic expression is written in this form, minimum or maximum value cannot be easily seen. We cannot easily see the maximum or the minimum when our quadratic expression is in this form. So we use a method, we use a particular method called what? Completing the square. To do what? To convert or change this quadratic form, which I used QF here to just mean quadratic form, to this a into x plus p the whole thing squared plus q form, which we actually refer to in function as the turning point form. We refer to this form as the turning point form. A into x plus p the whole thing squared plus q. We use that method. We call it the completing the square method. We are going to look at how do we apply the completing the square method and how do we actually convert quadratic expressions of this form to this form using the completing the square method. Now, as a basis of this method, here's something to note for you. And I want you guys to comment in the comment section and tell me, what is x plus p the whole thing squared equal to? Please write down in the comment section what x plus p the whole thing squared. What is it equal to? If you were to simplify x plus p the whole thing squared, what is it actually equal to? When you were in grade 10, my grade 10s I'm sure would answer this one because we just did products with them. Thank you, Gift. Okay, Gift just answered. I hope and I pray, guys, that there was no one that did this. And said the answer is x squared plus p squared. Yo, guys, this here, if you said x squared plus p squared, this here spells danger for a grade 11 learner. If you are in grade 11, and I worry about those people that are like coming into our live sessions, and maybe they are in grade 11 as well, but they look at this and they're like, guys, it's the 3rd of January. Are you kidding me? Schools have not started. Come on, relax, chill. I promise you now, okay, and this is something that I even noticed because last year I had the privilege of teaching in 2024. I taught a grade 11 class in the school that I'm at. And that grade 11 class, they did not start off well beginning of the year. And what I could sense was that they were still, in the festive mode in their heads. They had not as of yet actually sobered up. And what I mean by sober up, I mean they were not actually present in their minds as far as like the year that they were in and, and so forth. And so careless mistakes like this, happen when people don't really care about the basics of mathematics, doing the basic things. Yeah. Because a math student who's proper will realize, okay, we have x plus p, the whole thing squared. Inside this bracket, there are 2 terms. Are you with me? There are 2 terms. You don't apply the square to the individual terms inside the bracket if there's a plus or a minus in between those variables. You only do that when there's a multiply and a divide, because x plus p, inside the bracket, there are 2 terms, guys. There are 2 terms. So what we know then is we open 2 brackets. Okay. We say x plus p into x plus p. Then what do? We apply FOIL. You remember FOIL? Meaning you multiply the first terms in the bracket, you multiply the outer terms in the bracket, you multiply the inner terms in the bracket, you multiply the last terms in the bracket, and then you get your beautiful x times x, x squared, x times p, xp, p times x, another xp, and then p times p, you get p squared. Then you have like terms in the middle, so you have x squared plus 2xp plus p squared. So all in all, I am expecting that all of you should be able to simply tell me that x plus p, the whole thing squared, is equal to x squared plus 2xp plus p squared. Okay, this is grade 11. Once again, to those who are entering in, this is grade 11, and we are looking at how to find the maximum or the minimum of a quadratic expression, and we've been actually at it. Now we are currently looking at a method that we can utilize to convert a quadratic expression of this form to this form. Okay, but before that, I had just asked the learners to tell me what's x plus p, the whole thing squared. All right, and I did not want to see this nonsense, this one. You can't tell me that x plus p, the whole thing squared, is equal to x squared plus p squared. X plus p, the whole thing squared, it means you open 2 brackets of x plus p, a product of those 2, then what do? You apply what we know as FOIL. You multiply the first terms, you multiply the outer terms. So x times x is x squared. You multiply the outer terms, x times p is xp. You multiply the inner terms, p times x is px or xp, which is the same thing. And then you multiply p and p. Bases are the same when you multiply. You keep the base, you add the exponent, so it's p squared. Then you add the middle like terms. xp plus xp, you keep the variable xp, you add the coefficients. 1 plus 1 gives you 2. So it's 2xp in the middle. These are the basic things that as a grade 11 learner, I mean, it shouldn't be questionable that you are able to do this without even thinking at this stage, because in grade 9 and in grade 10, you were doing this. So at this stage, it should be pap and place. I don't know if pap and place is an easy thing to eat, but it should be. Okay, now, this is an important thing. Do you guys know what this is? X squared plus 2xp plus p squared. We call this a perfect square trinomial. I repeat, this is called a perfect square trinomial. When we factorize x squared plus 2xp plus p squared, what do we get? We get x plus p, the whole thing, squared. This is what we refer to as a perfect square trinomial. It is formed by a binomial squared. A binomial squared, when multiplied out, gives us a perfect square trinomial. When we factorize this, we get this back. When we expand this, we get that. So our understanding of perfect square trinomial will help us, because you can see clearly that there is a binomial squared in the form that you need to change from quadratic to turning point form. So this is very key, people. So that's why we need to know this. We need to understand this thing of perfect square trinomial. It will be assisting us in getting our trinomial quadratic expression, which is in the quadratic form, to this type of form, turning point form. Okay, all right. I hope at least the concept of binomial squared is clear for us, right? Let us continue. Okay, so we can use hey baba, hey baba, hey bana. We can use this fact of perfect square trinomial to write a quadratic expression in terms of a square and a constant. Guys, remember, you remember this form, this turning point form. It has a square and a what? This q, a constant. We can use this fact, this perfect square trinomial fact, to write a quadratic expression in terms of a square and a constant. This helps us to obtain or get the minimum or maximum value of a expression. Someone like, I don't know, like someone must say hallelujah like crazy, man, because this is like a revelation moment. But it is a revelation moment, and one of the things that is very sweet about the completing the square method is that it is so easy once we understand this concept of perfect square trinomial. Well, Laura, we are studying like crazy, and we want to kill it. We want to kill this maths, destroy it. Term 1 is gonna be nothing to us. Okay, so here's something to note then before we jump into the method of completing the square. Before completing the square using this completing the square method, something we need to note and we need to make sure that we always make right is that the coefficient of x squared must be what? Must be 1. I repeat, before we even jump into applying this completing the square method, the coefficient of x squared, right, must be 1. We must make sure that the coefficient of x squared is what? Is 1. So when you are given this form, we must make sure that the coefficient of x squared is what? Is 1 before we can complete the square. Right. So let's get into an example so that we can finally get this method out of our head, because it's making us go crazy, you know. We're like wondering, what's this method? What's this method? How do we convert a quadratic form into turning point form? Let's look at this. Let's go. We are asked here to find the minimum value of x squared plus 6x. Find the what? The minimum value. Now let's hold it a bit here. Are they correct in asking us to find the minimum? We need to question the question. Don't just jump into things. Question the question. Are they correct to ask us to find the minimum value of x squared plus 6x? Are they correct in asking us to find the minimum? Okay. Maybe one thing that can guide us. What is the coefficient of x squared? It's positive, right? Positive what? Positive 1. When it's positive 1, what did we say would be the form of this expression if it was expressed as a function? You know, it would be a concave up, meaning it would be a smiley face. So that means we have a bottom part, which is called the minimum. So are they right in asking us to find the minimum? They are spot on. Hey, these people, they're asking right questions. They're not asking us nonsense, these people. Hey, love these people. All right, we are going to get. Find the minimum value of x squared plus 6x by what? By completing the square. Oh, so they see, these people, that at the moment we have x squared plus 6x, so we have not completed the square. So we need to first complete the square. And then they are asking a follow-up question. For which value of x do we get this minimum value? All right. So first things first, we need to first take x squared plus 6x and do what? And complete the square. Now, what do we do when we are completing the square of an expression? Please, people, follow the leader, follow the leader, follow the leader. Follow me. So in the current state, we have x squared plus 6x. This is the quadratic form. Ax squared plus bx plus c. The c value is 0. It's not there, but we know it's 0. Do you see, guys? So this is the quadratic form that we have. Remember, what did we say? When a quadratic expression is written in this form, the minimum or maximum value cannot be easily seen. Are we together? So we cannot easily see the minimum or maximum value. So in order to do that, we use the method called completing the square to what? To convert this form to this form. Let's go. So remember what we said. We said before completing the square, the coefficient of x squared must be 1, positive 1. So if we look at the coefficient of x squared, is it positive 1? Yes, it is. So are we ready now to complete the square? Yes, we are. I repeat, is the coefficient of x squared 1? Yes, it is. Are we ready now to complete the square of the expression? Yes, we are. So let's start. Equal. Now, aslali la nasisi, aslali la. So let's go. X squared. Did you see that, guys? See how I placed that x squared? Plus 6x. So I've written down the x squared term followed by the x term. Now, this is what we do when we complete the square of an expression. We do the following. Please take note. We add half of the coefficient of x. Hey, there they go, these people again. There they go again. We have detected inactivity during your current live. Complete the verification. All right. Sorry, people, I'm back. So, x squared plus 6x, original. Let's look at the coefficient of x squared. What did we say? We said before we complete the square, the coefficient of x squared must be 1. So is it 1? Is the coefficient of x squared 1? Yes, it is. So therefore, what we do is we write out this expression. X squared plus 6x, and then this is what we do. This is what we mean by completing the square. We add half, okay? And this addition of half, the minute we say plus, we put in brackets half, the product of the coefficient of the x term. So what is the coefficient of x here? It is positive 6. People, we are always writing the x squared term first, then we write the x term second, then immediately after the x term, we write the following. We add half of the coefficient of x, which is, in this case, what is the coefficient of x? It is positive 6. If it was negative 6, we'd say half times negative 6. If it was 3 over 2x, we would say half times 3 over 2. So we are always adding half. That half is standard. It's always going to be there for everything. For all expressions. You're always adding half. The product of what? The product of the coefficient of the x term. Then what do you do after that? You square it. Yay, you square it. But what you have added, you are also going to do what? You are also going to subtract the same square. I repeat this thing. X squared plus 6x was the original quadratic expression. Now what have we done? We wrote down x squared because the coefficient of x squared is 1. Remember, we cannot complete the square until the coefficient of x squared is 1. So it is 1, which means we are ready to do what? To complete the square. X squared plus 6x. And always, guys, after the x term, we write the following. We add half. Please, this half, I want to underline what's always going to be there. This half. Then you multiply this 6. Where does it come from? It is the coefficient of the x term. And you're asking yourself, what is the x term, guys? The x term is this term. This is the x term. It's the second term of your quadratic expression. This is what you multiply by half. It's the coefficient of x is positive 6. If it was negative 6, we'd multiply half by negative 6. If it was negative 3 over 2x, we'd multiply half by negative 3 over 2. Please, guys, it's the coefficient, the number that you multiply, all right, by half. Are you with me? Then what do you do after that? You square it. Remember, this is the same thing as saying 6 divided by 2. Okay? I mean, it's the same thing exactly. Yes. Boitumelo, hold your horses, right? We don't divide by negative. Okay? We don't divide by it because this is not an equation, it is an expression. But hold your horses, we are going to get to an example like that. Let's first focus on this. This we are given that the coefficient of x squared is positive 1. Just stick with me. So we add half the coefficient, all right, of the middle of the x term. So the coefficient of the x term is positive 6. So the half is going to be standard and the squared will be standard. Are you with me? But what we add, we also subtract the very same thing. People, think about it. If you're adding something and you subtract that very same thing, what does that actually give you? It gives you 0. So in other words, this minus this is actually 0. All right? Which means this and that don't actually change the what? The quadratic expression. The quadratic expression is still the same.
because we are adding half the coefficient of the x term squared minus half the coefficient still of the x term, and we are squaring it. So this minus that gives us 0 back, and we are back at the x squared plus 6x expression. Are you with me? So this does not change the quadratic expression, but it allows us the chance to set up a perfect square trinomial from our first 3 terms. And please take note of my next steps that I'm going to do. If there was a constant term, then I would write that constant term at the end. Now obviously for x squared plus 6x, the constant term is 0. I mean, writing that 0 will have no effect. But if you had a constant term, let's say there was a plus 3, then you would write that plus 3 at the very end of the expression. Are you with me? So the first thing we need to do here, like I said, make sure the x squared term is having a coefficient that is 1, step number 1. 2, to then complete the square. If the x squared term is 1, we can go ahead and do what? Write the first 2 terms of the expression, leave the constant out for now, then we add half what? The coefficient of the x term. We square it. Minus half times the coefficient of the x term, and then we square it. Okay, now look at the next step. What do you see here? Now we have x squared plus 6x. Now I always do this as a teacher. I always encourage my learners to half times 6 gives me 3. Then you just do what? You keep the square. Minus, what's half times 6? It gives you 3. You keep the square on the outside. I hope you guys can see this, right? Okay, so you work out what is in the bracket. You keep the square on the outside. Now I want you to note something, guys. Remember when I spoke about what we refer to as a perfect square trinomial? Do you see that we have x squared plus 6x plus 3 squared? And I just want to write this on the side so that you can appreciate this. X squared plus 6x. The 3 squared, what is that equal to? The 3 squared gives me a plus 9. Are you with me? This is what I refer to as a perfect square trinomial. Right? We've just set up so that our first 3 terms have a perfect square trinomial. What do? We factorize this perfect square trinomial. We factorize this perfect square trinomial. We factorize this perfect square trinomial. And in order to factorize it, what's x squared plus 6x plus 9 when we factorize it? All right, so I'm hoping you guys can see. You're going to open 2 brackets, x squared plus 6x plus 9, that gives us x this side. Then the factors of 9, when we multiply these numbers, they need to give us 9. When we add them, they need to give us plus 6. You can see that these are the same bracket, x plus 3 into x plus 3, which is actually what? X plus 3, the whole thing squared. Can you guys see that? I just wanted to do this so that you guys can appreciate what completing the square actually, the opportunity that completing the square provides for us. Okay, so I repeat this thing here. When we added half the coefficient of the middle term and we squared it, and then subtracted half the coefficient of the middle term, then we squared it. What we were doing is we were setting up these first 3 terms so that we could form a perfect square trinomial, which we then have to do what? Factorize. What do you need to do to do it? You need to factorize it. And there it is, guys. There it is. You factorize it, you get x plus 3, the whole thing squared. Are you guys with me? Are you with me at least up until this point? Okay. And then we can now conclude. Maybe you're going to ask yourself, why, sir, do you insist that your learners keep this 3, all right, and square it, it's because of the following thing that I'm going to do right now. The marks, when you've got x squared plus 6x plus 3 squared, the next thing that I usually say to my learners to just shortcut the factorization of this trinomial. Take the x here, take the square root of this x squared. What do you have in your bracket? An x. This is 3 squared. So the number inside the bracket already tells you what's the square root of 9. It is 3. The sign of the 3 inside the bracket is positive. All right. So obviously this is a positive 3. So you write a positive 3 inside the bracket. And then you just put a square there. Right. Guys, this is just me shortcutting things for learners. All right. So this x squared, you just write x, the square root of x. Then this 3 as it is, you write it, okay, inside the bracket. This is basically the factorization of x squared plus 6x plus 3, the whole thing squared. But guys, remember, you can go ahead and just make, you could always just write this out, x squared plus 6x plus 9, factorize it properly, and then get this x plus 3, the whole thing squared. Are you with me? Okay, I hope you guys are with me. Luyolo MN, I don't know if I understand you. What about minus? You have the minus outside the bracket. We are coming there. We're getting there. Then this here, remember, this here is our constant term that will be next door. This 3 squared minus this 3 squared will be equal to 9. Okay. So obviously you are going to square this 3, this becomes 3 squared, and then the minus is outside the bracket, so this is actually minus 9. So this is your form. We have just completed the square of the expression x squared plus 6x. Do you see? We have x plus 3, the whole thing squared, minus 9. Now, this is how we complete the square of the what? Of an expression that is quadratic. So just recap one more time. The initial quadratic expression, x squared plus 6x. Are you with me? Then, what did we say we need to make sure happens before we even complete the square? We need to make sure that the coefficient of x squared is 1. We always need to make sure of that first before you even go ahead and apply this method. So then you write down x squared plus 6x. You hold it right there. After you write the second term, you hold it right there. You then add half in brackets times the coefficient of x, which is 6. The coefficient of this x term is 6, positive 6. So you have times 6. Then you square it. Don't forget to square it. But after adding this, you also subtract the very same thing. Okay. Yes, pretty much, Boitumelo. If you half times 6 is the same thing as 6 divided by 2. But I just insist, because remember, sometimes the coefficient of x can be a fraction at times. So that's why I insist on half times a particular number. Okay, so that you can always sort of like deal with multiplication. Remember, even when you were doing in grade 8 and 9, whenever you had a division between two numbers, you always change the divide to multiply, by inverting the second fraction. Then you would actually get your answer after multiplication. So that's why multiplication is actually safe, right? So it's always half times the coefficient of the middle term. That's in the case when you actually have a fraction that is the coefficient. So halving, okay, is always safe, if you know what I mean. So it's always half times the coefficient of the middle term, the coefficient of the x term. You square it, then you also do what? You subtract the very same thing, half times 6, the whole thing squared. Remember what I said about this adding and subtracting of the same thing does not change the quadratic expression. But what does it do? It helps us set up a perfect squared trinomial from our first 3 terms. Now, if you write this down, it's x squared plus what? Plus 6x plus what? What's half times 6? it's 3 inside the bracket. It's positive 3 inside the bracket. And then you put the square on the outside. Then you have the minus for this term here. This one, this guy here. Half times 6 is also 3. The whole thing what? Squared. Then remember, what did I say about the first 3 terms? They form a perfect square trinomial. Okay, now we practically just went to see that x squared plus 6x, what's 3 squared? It's actually 9. Just so that we can see what we mean by this. If you take this and you factorize it, if we factorize this, we get what? We get x plus 3 into another x plus 3, which is actually x plus 3, the what? The whole thing squared, because it's 2x plus 3's squared. Are you with me? Okay, so hopefully for my people that earlier on were saying x plus p, the whole thing squared, is equal to x squared plus p squared, you are now seeing why it's foolishness to square the first and the last term and to say that's your answer. But why it's important to actually expand and multiply out. Okay, I hope you guys are with me. Given Jan is saying, Mr. Can you please help us? I don't know, WH, what does that mean? So x plus 3, the whole thing squared. I hope you guys can understand that, okay? I hope we are together there. Then, x squared plus 6x plus 3 squared. I did say if you leave it in this form, what becomes very nice and easy is that you know from this will come the binomial squared bracket. That's basically what this is all for, these first 3 terms. The quadratic expression, the perfect square trinomial, is supposed to lead you to the square bracket, all right? And then this term here will be your q value, which is the constant term. I hope you are with me. So I said you just take the square root of x squared, you write x in the bracket, take the 3 as it is, you write it as your second term inside the bracket. If it was negative inside the bracket, you write -3. But since this 3 is positive inside the bracket, you write +3. This is the number inside this bracket, whatever that sign is. If it's +3, you write +3 here. If it was -3, you write -3 here. The whole thing squared. Okay, and then last but not least, you write this last term, constant term, which is -3. What's 3 squared? It is 9. Remember, the negative sign is not inside the bracket, it is outside the bracket. So this is negative, and then 3 squared is 9. So negative times a positive is -9. Okay, I hope you guys are clear. Now, the question did not even say, they said find the minimum value of this. Okay, so now that we've completed the square, what is the minimum value? Minimum value is equal to, hopefully you guys can tell me, what's the minimum value? Okay, because now we have it in this form. Where did we say we get the minimum value? The minimum value is the q value, so the minimum value is equal to, very spot on guys, it is -9. 100%. Okay, 100%. Okay, I don't know, I see this messages that you guys are writing, so can you please help us with, and then last but not least, they asked for which value of x do we get this minimum value. Remember, where do we get the answer from? For that, we look at our expression inside the bracket squared, okay, x plus 3, we equate that to 0, which means x is equal to, we transpose the +3, we get x is equal to -3. Okay, guys, are we feeling this? Are we feeling this? All right, I hope we are. I absolutely hope we are. I think I'm gonna do another one, but in this situation where there's a negative, so that we can I think these guys need to just, I know some of you got the answer very quickly, that's fine, I'm happy for you. But remember, when you are teaching a class, you want to sort of like get even the people that are, you know, a bit, who may not have gotten it very well as well, okay? So I'm going to do 2 more examples. The grade 12s, if they are here, they just need to hold on their horses. I think we'll start a bit later, unfortunately, because I want to finish up this. Yes, this will be posted on YouTube, of course, but obviously probably later on, much later, because I have a grade 12 session after this.
Okay. Now listen, guys. Let's look at this one. Y is equal to negative x squared plus 8x minus 5. Now, do you see an expression that is quadratic mirrors a function? An expression is a function, guys. Expressed in another way. All right. So an expression and a function, they sort of like have a same WhatsApp group. Y is equal to negative x squared plus 8x minus 5. So let's do this. Let's write this negative x squared plus 8x minus 5. What they want us to do is to determine the maximum value of. Are they correct in asking us for the maximum value? So the coefficient of x squared is negative. Are they correct in asking us for the maximum value? Are they correct in doing that? Or definitely they are. Because remember, negative means sad face. Sad face means we have a maximum. All right, so it makes sense that they're asking us for that. It's always nice to think about these things so that you don't just answer a question and maybe they ask the wrong thing. You need to be able to pick up on those things. That means you're actually understanding what you're doing, not just doing it for the sake of doing it. So negative x squared plus 8x minus 5. All right, negative x squared plus 8x minus 5. First step, what did we say? We need to make sure that the x squared term is what? Is positive 1. Is it positive 1? No, it isn't. So, if not positive 1 x squared term, what do? We take out negative 1 or whatever that coefficient is, guys. If it was 2, we take out the positive 2. If it was 2 over 3, we would take it out. Please be with me here. We take out whatever that coefficient is if it is not positive 1. But people, what do I mean by take out? I mean the following. You take out negative, then in brackets you write x squared. If you take out a negative, what is left inside the brackets? X squared. 8x becomes negative 8x. Negative 5 becomes positive 5. Are we together? Okay. Why are we doing this? It's because this is a quadratic expression. It is not an equation. Right? The misconception that learners have when they are doing this is they think that this is an equation and then they divide by what? By negative 1. We cannot divide by negative 1, guys, to get rid of the positive, because this is not an equation. If there was a left-hand side and a right-hand side and you were completing the square of an equation, it would make sense if you are dividing by a negative. But we can't just simply change an expression, all right? Because we can't change an expression and make it what it wasn't. Because by doing that, if we divide by negative, if we divide this expression by negative, we are changing the expression completely. It does not retain its previous identity. But look at this. If I take out a negative, all right, for this expression, am I changing the expression? No, I'm not. Because this negative is always ready and waiting to go back and basically return to its original state. Are you with me? So an expression, guys, please we take out things when an expression is concerned. Are you with me? I hope you guys are with me. I really hope you are with me, because dividing by a negative or dividing by whatever changes the expression. All right. So we take out a negative, first step. Now that the negative is out, we can focus on our quadratic expression inside the bracket. We can focus on that by applying the methods that we learned, which is step number 2. We add, and what? We add, after the x term, we add half the what? The coefficient. What is the coefficient of x in this case? It is negative 8. And then we do what? We square it. But after adding, what do? We subtract. Please, people, the order is important. You don't ever start with subtracting it. Please, let's always start with adding, and then we'll follow with subtract. Let's first be positive. We need to always be positive in life. Yeah, and I'm not saying we should be negative after that. Please, people, let's always start with plus.
because the trinomial, the perfect square trinomial, will be formed if there's a plus and not a minus. Are you with me? So we add half the what? The coefficient. The coefficient of x is -8. Then we square it. Then we do the same thing, Moss, with subtraction, half the coefficient squared. And then remember, there's a constant now. Our constant term is what? Is +5. So our +5 needs to be there at the end. Very important, because we actually do have a constant term. Do you see? This is all in brackets, all of it. And I've distinguished my big bracket to accommodate everything from my smaller brackets to accommodate what I've halved with the coefficient of the x term. Okay, step that's following, x² minus 8x. Remember, what did I say? Half of -8, positive times the negative, we have -4, the whole thing squared, safe, minus -4, the whole thing squared, safe, plus what? +5, safe. Man, I'm feeling good, I'm feeling good, I'm feeling good. It's coming together, it's coming together, it's coming together. Any questions? This is grade 11, guys, this is grade 11. Grade 12, just wait for me, please. Hold your horses, I'll be with you soonest. X² minus 8x plus -4, the whole thing squared, minus -4, the whole thing squared, plus 5. Then, what do we notice? The first three terms, our perfect square trinomial. This would be x² minus 8x plus what? Plus 16. Grade 9 will be tomorrow morning at 7 o'clock, 7 a.m. And then grade 10 will be following that at 8 o'clock. So grade 9, 7 a.m. and then grade 10, 8 a.m. tomorrow. So x² minus 8x plus -4. So if we were to take this perfect square trinomial, remember our next step after this is we need to do what? We need to factorize. We understand that this is a perfect square trinomial. And I'm sure already on 30, what time? Grade 12 will be done shortly after this session, and I'm pushing it a bit. So 10 to 11 guys, 10 to 11. I'm sorry, man. It's just that this session is going a bit longer than I anticipated, and for perfect reasons, of course, because this is a critical section which needs a bit of time. So x² minus 8x plus minus 4 squared. Remember what I said here? You can take this x² minus 8x. Inside the bracket, you have positive 16. I'm sure you can factorize this, guys. I'm sure you can. If you open two brackets, we have x, we have minus 4, which is x minus 4. The whole thing, what? Squared. Can you see that, right? Okay. NM Felang, I don't do first years. You're funny, man. X minus 4, the whole thing, squared. All right. Remember, I said when we at this stage, you can take the x, you write it down, and then you take what's in the bracket minus 4, you write it down. This is just a shortcut to not really think about the factorization of the perfect square trinomial. But please, people, if you feel more comfortable in actually writing this x² minus 8x plus 16 out and then factorizing, please, by all means, do that. Obviously, it's safe, so that your trinomial actually comes out with the binomial squared that is 100% correct. Are you with me? And I advise that if you feel very strongly about it. Okay? All right. Remember that for these three terms, I've just introduced a what? A bracket. But remember, there was a bracket that was over everything. So I need to still keep that. The big bracket that was over everything. I'm still keeping that. It's not going anywhere. So I have now a x minus 4, the whole thing squared. All right? And let's go. Then we have minus. Remember now, bad maths, not board maths. Bad maths says you must first look at the brackets, then followed by the exponent. That's what bad maths says. Brackets, then exponents. We can't take this negative and multiply it inside. We can't do that before we take care of the exponent and the number. So what's negative 4 squared? It's positive 16. And then positive 16 times negative gives us negative 16. Then we have a plus 5 that follows that. Okay? And this covers the big bracket for everything. All right? Now, we are not done.
Let us simplify. Okay, let us finish off by simplifying. So this minus into x minus 4, the whole thing squared, minus 16 plus 5. What's minus 16 plus 5? If we work it out, minus 16 plus 5 is negative 11. We are not done. We are not done. We are not done. We are not done. Then you take the negative, you distribute it to the bracket first. This first bracket, you will get negative into x minus 4, the whole thing squared. But this minus stops outside the bracket because there's a square. BEDMAS does not allow minus to go inside this bracket, this x minus 4 bracket, because there's a square there, right? BEDMAS does not allow minus to go in. All right, so we have minus into x minus 4. Then negative gets distributed as well to negative 11. Are you with me? Negative times negative 11 gives me positive 11. So in other words, y is equal to negative into x minus 4, the whole thing squared, plus 11. Okay, are you with me? I know. Scary. Okay, right. So if there are any questions, please, people, and there are critical brackets here that need to be there. Those critical brackets, guys. All right, please do take note. All right, remember that from my trinomial, there was this bracket that was formed because of the trinomial. We factorized it, so it's x minus 4, the whole thing squared. The x single variable without the square, minus 4 without the square, inside the bracket makes my x minus 4, the whole thing squared. Remember, you could obviously write it out as the perfect square trinomial and factorize it. That's also fine if you want to do that, so that you can have the accuracy of doing that. Then you have x minus 4, the whole thing squared. That's for this trinomial. But the big bracket you had initially for the entire expression, please, guys, that still needs to be there. Then please be careful with this. Minus into minus 4 squared. Minus 4 squared, the square gets priority over minus 4. So minus 4, the whole thing squared, is positive 16. Then positive 16 times negative gives you negative 16. Plus what? Plus the 5. Then remember, that big bracket is still there. There's a negative sign that's still waiting very patiently. Hey, very patient, that negative. Minus 16 plus 5 gives us negative 11 initially. Then remember, that negative needs to be distributed first to this first term square bracket, and then the negative needs to be distributed to the negative 11. So we get an answer of y is equal to negative brackets x minus 4, the whole thing squared, plus 11. This, guys, is our quadratic expression having completed its square. Okay, Siavana, are we together? Yeah, hopefully we are. Then the question was determine the maximum value. That's what we wanted, remember? Yeah, so we have now a maximum value, right? And the maximum value is what? That's what they asked. They didn't ask for anything else. They didn't ask for the value of x for which we get the maximum. So we are going to answer the question specifically and not give things that have not been asked. So our maximum value here is equal to what? Someone tell me. I'm waiting. Then I can do the last one, guys. The last one, I think, for the evening. Maximum value is 11. Amen. Hallelujah. Amen. Where do we get the maximum value? It is always the value of q, the constant term. And remember, had we not distributed the negative, we would have probably gotten the q value or the maximum value incorrect. So it's so important, guys, these brackets that we have in place here, that ensure that we are able to retain the integrity of the answer at the end of the day. Amen. Amen. Hallelujah. I don't know if there's any amens that are here. NM Felang, what's happening here? This guy is here wanting clapping hands and all of that stuff. Okay, let's do the last one for the night, so that we can be all together, and I can actually turn my attention over to the grade 12s. I'm sure they are getting all sorts of impatient now. They're like, hey, this guy, what is up with him? In actual fact, they need to know this as well. All right, let's go. Completing the square is still an important concept that you need to apply. There's other things. So look at this one. Determine the minimum value of 2x squared plus 3x plus 5. The question is, are they justified in saying determine the minimum value of 2x squared plus 3x plus 5? We need to think about that. So if we look at the quadratic expression, the coefficient of x squared is positive 2. The positive 2 in and of itself says what to us? Okay, it says what to us? It says that the function is a happy guy, positive, happy guy. So that means happy guy, happy face, we have a minimum. So are they justified in asking us for a minimum? Yes, they are. It can't be a maximum. Okay, I hope that makes sense. Next, we look at the quadratic expression. What do we see? Is the x squared term having a coefficient of 1? No, it doesn't. So what do we do in that situation? Thank you, Leolo. That's very kind of you to say. What do we then do? We must then take out the coefficient of x squared. For all terms, take it out. So when we take it out, what happens? We are left with x squared for the first term. For the next term, we are left with 3x over 2. Please, guys, take note of this. Take note of this. Because 2 is a factor of 2, when we take it out, we are left with 1. Because 2 goes in exactly to 2. How many times? Once. Are you with me? 2 does not go into 3. Because 2 is not a factor of 3. But when we take out 2, we then have to make sure that in our denominator of the actual term, we write the value that we have taken out. Because what's 2 times 3 over 2? The 2 and the 2 would cancel out, would get the 3x back. Does that make sense? Okay. So we always write, no. King Mac, I think when you just walked into the session, which means you don't understand what is even happening with this particular problem. King Mac, it's very sad because King Mac is asking, why don't you use the quadratic formula? Please, people, I'm sure you understand why. And as grade 11s, we don't even know what that is. We are not even there yet. And in actual fact, this completing of the square method does not even require that type of usage of that formula. So King Mac, hold your horses there, my man, until further notice. So we took out the 2 for the x squared, we left with x squared. We took out the 2 for the second term, so we have 3 over 2x. Okay. Then if we take out the 2 for 5, we have, I'm sure you guys got it, we have 5 over 2, because 2 is not a factor of 5. Are you with me? So we write 5 over 2. So all of what we've taken out appears in the denominator the minute that particular number is not a factor of the number that we've taken out. Are you with me, guys? The minute the number we have taken out is not a factor of the number that we are talking about, then that 2 will appear in the denominator. Because 2 times this, the 2 and the 2 will cancel. It's gone. We are back here. 2 times 5 over 2, the 2 which is in the numerator and this 2 which is in the denominator will cancel out. We are left back with the 5. Okay, are you with me? So hopefully we get that. Now we officially have an x squared term that has a coefficient of 1 inside the bracket. So the 2 will stay outside in the cold, and everybody else, all 3 terms inside the bracket, will stay inside the house in the warmth of the house, because they are living in America and there's snow at the moment. So let's go. Now we can complete the square. We are ready to complete the square because the x squared term has a coefficient of 1. Let's go. Plus 3 over 2x. Okay. Now we add half times, what is the coefficient? The coefficient of x, which in this case is 3 over 2. So we half 3 over 2 and we square it. Okay, are you with me, guys? Are you with me? I hope you are with me. Yeah. And then, okay, I don't understand what this person is saying. If it is a half, I don't understand what he's saying. Okay, then we subtract half, again, the coefficient of the middle term, which is 3 over 2. And that 3 over 2 is positive, guys. So that's why we're saying half times positive 3 over 2, and again half times positive 3 over 2. We don't forget the squared. Learners tend to forget the squared sometimes. Hey, don't forget it, guys. Don't forget the square. And don't forget to start with plus and then follow it with minus. And remember, these first 3 terms will help me form that trinomial when the time is right. And then remember, there was a constant 5 over 2, so I write 5 over 2 and then the bracket that closes. Sisonke mos. We are together. Together forever. Man. Together forever. Together. Alright. Okay. Guys, this is what I call this is what I call niceness. Then we continue x squared plus 3 over 2x plus what's half times 3 over 2? That gives us 3 over 4. Right? In brackets, we square it. Are you with me? Then minus half times 3 over 2. Still, that's 3 over 4 in brackets squared. Plus 5 over 2. We close the sweet bracket. Okay? Yeah. There we have it, our trinomial. Okay? Can be factorized. So obviously our perfect square trinomial now needs to be what? It needs to be factorized. Okay? And like I said, guys, you could write that perfect square trinomial out, but like I said to you guys, we shortcut it, and it's a nice, beautiful shortcut. We know the factorization. It's not like we don't know the factorization. We know it very well. All right. So we are going to create now, from this first 3 terms, we are going to create a bracket squared, right? We take this x squared, the square root of that is x. So basically what's inside the bracket is x, it's positive. And then inside this bracket, it's 3 over 4. And the 3 over 4 is what? It is positive, the 3 over 4. Okay, squared. Then remember, we still have a big bracket for all the terms inside the bracket. But we have sorted out the factorization of the first 3 terms. Took the x, took the 3 over 4 without their squares. We took the x as it's positive, and the 3 over 4 inside the bracket, it is positive. So that's why we have plus 3 over 4, and we square it. That will give us, if we multiply this out, it will give us these 3 terms back. Okay, then we look at the last 2, minus 3 over 4, the whole thing squared. We take care of what's inside first. 3 squared is 9. 4 squared is 16. That 9 over 16 times by this negative is negative 9 over 16 plus 5 over 2. Then if you are like feeling like, I don't want to be calculating these things with my head, then go grab your scientific calculator, man. And you know what? If you do that, you don't even have to actually work it out as per just grab your scientific calculator. That's negative 9 over 16 because you really just want to make sure you get the answer, and this is perfectly fine if you do that. Okay, you don't have to manually get the answer using the addition. You have 31 over 16. You see, that was negative 9 over 16 plus 5 over 2. It gives me 31 over 16. So then I can go there, 2 into x plus 3 over 4, the whole thing squared, plus 31 over 16. Now strategical, remember, I had still the big bracket. Now I need to remove the big bracket because I have to write that in the turning point form. So the 2 multiplied with the binomial bracket squared gives me 2 into x plus 3 over 4, the whole thing squared. Remember, the 2 stays outside. It can't go in because the square term, the square exponent, basically keeps everything in check. The 2 can't go in without the square being resolved. And obviously the square will not be resolved because we want this form. Plus what? 2 times 31 over 16 gives us 31 over 8. You distribute the 2 here, 2 stays outside, you distribute the 2 to the 31 over 16. The 2 goes into 16 how many times in the denominator? 8 times. So we have 31 over 8. Therefore, what do they want? The minimum value. What is the minimum value? Minimum value equal to 31 over 8. Right? Guys, singeyivala ngithi qim shelele. Singeyivala ngithi qim shelele. All right. Looking good, looking great, guys. Okay, any serious burning questions before grade 11? I bought you, yeah, I do have some work for you guys to do, by the way. I'll post that in the group. Yeah, I'll post that in the group, but it would be nice if you can even utilize, there's the textbook, guys, that one, that New Mind Action Series textbook, the exercise that follow immediately after maximum and minimum. Please, guys, do those, all of them, not just some of them, do all of them, okay? You can get them from some of the people that are here. There are some people here that are in the grade 11 group. They can actually, just please, guys, let the guys who are in the group, please let them know, so that they can actually divert the relevant details to you guys. I unfortunately cannot do that at the moment. Due circumstances. You can always send me a message. I'll get it after the live session, and then we'll see how we can go about doing that. Please, guys, the exercises, the game challenges are there, man. In that textbook, there are so many there. There are so many. Maybe if I can get, sorry, I'm just trying to start up this thing so that I can see. Maybe I can show you. You guys can actually go ahead and do them. I'll take a screenshot maybe of the actual things, and you can do them. Remember, guys, all of this that I've taught will be futile if you do nothing about it. If you simply are like, oh, this is so great, I finally understand it, but you literally don't do anything about it, you don't actually switch off the live after I'm gone and you go do a few, then you have actually failed yourself, if you ask me. Please, guys, screen grab. There we go. Thank you, Pano, for the rose. I really appreciate it. Thank you so much. I appreciate the parents that are referring the people to the live sessions and all of that stuff. That is really sweet. So please, you can do these, guys. Look at this. There's screenshot, guys. There's ADG. You can do this. You see, for each of these, you need to state whether it has a minimum or a maximum value. That's where you need to start. State first, is there a maximum or a minimum? All right. Then 2, you need to determine the minimum or maximum value for each. And then 3, you need to give the value of x for which the minimum or maximum value is obtained. All right. And obviously, for all of these, in order to answer these questions, at least number 2 and 3, you need to complete the square of each expression. So you guys can do these, like I said, and then after you are done, send me your attempted work, what you have done, so that I can mark it, right? Those who are in the group will know we did exponents and surds. A test has been written. I set a test. The people that were really serious wrote that test. Someone in this group totaled the test that I set on exponents and surds, and some of the people got 92%, some got 88%. Some people did not do as well as they would have wanted to, and so it gives them a chance to actually go back and go and close the gaps where they need to close the gaps. So it's very important, this thing. All right, very important. For me, I'll be doing grade 12 just now. It's just that, like I said, sometimes life happens, and when life happens, it happens. So there becomes delays and all of that stuff. So please, guys, screen grab, do these, and then you are more than welcome to send your responses to me so I can check your work, and then we can take it from there. But remember, learning without attempting and practically doing on your own, it still means I know the work, you don't know it. But in order for you to know it for yourself, understand it, internalize it, make it part of you, be excellent at it, master it, you have to do it. And if you do it, and you do it consistently, then flames, my man, you'll be showing maths flames. You will be the one showing maths flames, not the other way around. I'm sick and tired of hearing people saying to me, maths showed me flames. It showed you flames because you like flames, man. You like being shown flames. You need to start showing maths flames. You need to show maths flames. That's still a while off because I'm going according to the ATP for each term. So grade 12 Euclidean geometry only comes literally at the end of this term, term 2 topic, but at the end it kind of like there's a introduction of grade 11, and then term 2 is when it actually is full on there. But maybe if we are already starting with term 1 topics in grade 12 now, maybe we'll be having those maybe even earlier than what you guys are doing at school. Kopano, do I tutor? Yes, I do tutor. What I'm doing right now is tutoring, and it's very key, this thing, very key, Thank you so much, guys. Let me love and leave you now. I'm sure you have done the things. I see NM Felang says he tutors life orientation on YouTube. Maybe you can definitely check him out, Mr. NM Felang. I appreciate helping other people to actually promote themselves, especially if you are here, if you are doing genuine work and you are helping the nation, then I'm happy to promote that good work. There are great people on this platform that are doing some amazing things and are doing above and beyond even what I'm doing, so it's actually good. Okay, so hopefully we've grabbed these. Guys, 4, 8, 12 exercises of completing the square and then answering 3 important questions about each quadratic trinomial which will have completed the square. Do these, guys, and do them. Immediately after you leave, do them. Okay, do them. Okay. YouTube account is still, maths is a game, guys. Maths is a game. You can go onto my bio, you can go onto the Landoga, and you can, NM Felang, you're asking. NM Felang, you must tell them what is your YouTube account so that they can actually do the things which need to be done. Guys, I need to close this session so that I can start up with grade 12. Grade 12, I think we are starting at 11, but I need to close this session so that it can save this recording for now. Goodbye, guys. Thank you so much. I hope it was good. I hope you guys really got something and you are confident. No, don't worry, Lelo. That's one thing I can't forget to do. I can't forget uploading the session. It's very key, that one. It's very key. Okay, goodbye. Danko.